This is the WJEC Numeracy Intermediate paper from November 2017. First question says, Dragon's Bridge opened in Rhyl Harbour autumn 2013. The harbour had a development cost of 9.8 million. 4.3 million was spent on the bridge. So I would do 9.8 take away 4.3 to work out the cost. So that's going to be 5.5, but that would be million. So to work this out now, I need to know which one of these it is. So million, so think of your place values. So we've got units, tens, hundreds, thousands, hundreds of thousands, millions. So you've got 5 going in the millions. 0.5 would be the hundreds of thousands. So 1, 2, 3, 4 zeros there. I've missed something. What have I missed? Tens of millions, tens of thousands. So it would be this one here. So it's got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. It's that one there. It then says a newspaper said that this bridge provides the final link in 15 miles of traffic-free cycling across Conway and Denbighshire. Write 15 miles in kilometres. Now to do that, you need to be aware of this conversion. If you don't know it, you need to learn it. You should know that 5 miles is worth 8 kilometres, and they're asking me to work out what 15 miles is. So that means I've just times that side by 3, so I times that side by 3, and get 24 kilometres. For part C, it says, the height of the mast of the bridge is 148 feet. Using the conversion, 1 foot is equal to 30 centimetres. Calculate the height of the mast in metres. Now, they put that in bold, and that's because that's in centimetres, so they expect you to change that. So 1 foot is equal to 30 centimetres. I've times that by 148 to get 148 feet, so I need to times this by 148. So I'm going to split up the 148 into its components of tens, units and hundreds. I'm going to times it by 30. No need to split that up because it's already as a 10. So 3 times 1 is 3. 1, 2, 3 zeros. 1, 2, 3 zeros in there. 3 times 4 is 12. And then 1, 2 zeros. 1, 2 zeros there. And then 3 times 8 is 24. And 1 0 there. So then it's going to be 3,000, 1,200, and 240 that I'm going to add together. 0, 4, another 4, and another 4, which would then be, so it would be 4,440 centimetres. And then to put that into metres, I'll divide that by 100 because 100 centimetres equals 1 metre. So it would be 4.44 metres. Question 2 says 4 different supermarkets have special offers on the price of lemons. So we've got Cost for Go, Edges Mart, Food Uno, Food Uno and Greenway. Alan needs 6 lemons to make his lemon cakes for his birthday. So he needs 6. Now if you look at these offers here, we've got 3 for the price of 2, a net of 4 lemons, a bag of 5 lemons, and lemons only 26p each. So we need to try and work out the best deal to get 6. It says, in this question, you'll be assessed on the quality of your organisation, communication, and accuracy in your writing. So that means we'll do the maths first and we'll explain what we did. Aled only has time to go to 1 supermarket. Calculate how much Aled would pay in each of the supermarkets. In which supermarket will he be able to get the lemons he needs for the least amount of money? Okay, so let's work on this one being number 1, 2, 3, and 4. So for Cost for Go, 3 for 2. Well, how much? Lemons usually cost 40p each. Now on offer 3 for 2. So I'm going to buy 2. So 2 lemons, which would cost 40p times by 2, which would equal 80p. But we get 3. But that's only half the lemons he needs, so then I'll have to double the price to get the 6 lemons. So 6 lemons will be twice as much and I'll show the calculation because I'm assessing the quality of my organisation and communication. So 80p times by 2 would equal 160p, which is £1.60. Okay. For the next one, 2, you get 4 lemons for 75p, but this is not enough. So I need to get certainly twice as much. They come in bags of 4, so it's going to be 2 times 75p, which equals 150p, which equals £1.50. Note I'm not putting 2 equals on one line. It's mathematically bad practice to do that. So it's 10p cheaper, isn't it? 10p cheaper and 2 more lemons. So that one's definitely better off than the first one. Then to work out for the third one, which is food uno, we get 5 lemons for 76p. Not enough. So we need to do 10 lemons would be twice as much. So it would be 76p times by 2, which would be 156p, which is £1.56, but 4 more lemons. So still cheaper than the first one, but more expensive than the other. 4 more lemons. And then number 4, lemons only 26p each, so 26p times by 6, so I'm going to set it up like that. 6 times 6 is 36, but I'm the wrong bit there, the 3 should be carried. 2 times 6 is 12, add the 3, it's 156p, which is equal to £1.56. Now that's not very neat, so if I was told that I'm being assessed on the quality of my written communication, it might be an idea to write that out a bit neater. So let's say 26 times by 6 is equal to, I can just write that answer from before, I don't need to do the calculation again. So £1.56 for 6 lemons. I need to make sure that I've answered what the question says. So the question says, calculate how much he would pay in each of the supermarkets. Yeah, I've done that. In which supermarket will he be able to get the lemons he needs for the least amount? So the least amount, I believe, was £1.50. So this is the cheapest. But I'm going to make sure that's really obvious in my final answer. So, and that was Edge's Mart. Edge's Mart has the cheapest deal. And you get 2 more lemons. And you get 2 more lemons than needed. Part B says, Alan can use any leftover lemons to make muffins. Which supermarket gives the best value for money? Give a reason for your answer. Well, in terms of that, then it's probably number 3, because for 6p more than the one that we just chose, you get another 2 lemons. So I would choose Food Uno. For another 6p, you get 2 more lemons than Edge's Mart. If we wanted to, we could even go and work out the price per lemon, but for 1 mark, I don't think it's worth doing that. I think that'll be enough to get that mark. Question number 3. It says, Mehmet needs a new fence for one end of his garden. Fences are constructed using panels and posts. Posts are needed between each fence panel and at both ends. How many posts are needed to make a fence with 34 panels? Okay, well, I'm going to label these 1, 2, 3, 4. So I've got 4 posts, 1, 2, 3 panels. Okay. So the relationship I'm noticing there is that for the number of panels, I have one more post. Is that true if I cover one up? So for 2 panels, I have 3 posts, and then for 1 panel, I have 2 posts. So if he's got 34 panels, he must need 1 more post, so I think it's 35. The next bit says, the fence Mehmet wants to make is 8.5 metres long. Mehmet needs to use 5 posts. Work out 1 possible choice of panels that Mehmet could use. You may use the plan to help you. Calculate the cost for the posts and panels and the fence of his choice. So we've got all of these different ones here. Now, are we told how many he needs? He needs to use 5 posts. So out of that 8.5 metres then, we already know that how long is a post? So we've got to work out which bit we want. It's 10 centimetres, but they've done that in metres. So this is 0.1 metres. 0.1 metres there. And if we're going to have 5 of them, we want to do 8.5 metres. And so 5 lots of 0.5 would be 0.5. Take away 0.5 metres would equal 8 metres of panels. So from there, I would probably look at that and trying to split that between, well, we just use this relationship that if there's 5 posts, there must be 1 less panel. We just did it the other way around. I would look at that and say, well, let's try and get that between 4 panels. So that would be 2 metre panels in length. So have we got that? Yeah. So if we choose the medium, so let's say per panel. So if we choose 4 medium panels, they will all have the same width. So it'll look like symmetrical. It would look weird having like, if we chose, because you could choose if you wanted, or we couldn't choose 4 of the large ones so don't overfill it, but you could choose a number of those and fill them in with smaller panels. But I think it would make sense to have them all the same size. Choose 4 medium panels as they will fit perfectly. And then it says, calculate the total costs. And if you look at that, it's 6 marks. I probably haven't done enough to get 6 marks there. So 4 panels at £30 each. It says here, £30 each. And then the posts, that's £14 each. So that's going to be 4 times 30 equals 120. And then 5 posts and they're £14 each. So that's going to be 5 times by 14. Don't know 5 times 14. 5 times 12, 60. So then 13 would be 65, 14 would be 70. So I then just need to add those 2 numbers together to get £190. It then says it costs 2p to paint each 100 centimetres squared of a fence post. How much will it cost to paint the full vertical sides of the fence post? So if I just draw out a rough sketch of what a fence post looks like. And they're working in centimetres squared here, so I'll want to work in centimetres then as well. We know from this diagram that 10 centimetres square, and then 1.5 metres would be 150 centimetres. So 10 centimetres, 10 centimetres. Okay, so we've got, if we call this side A, the front of this one B at the side, for side A it's going to be 10 times by 150. And then you're going to have that, in fact actually A, B, C and D going around the post, they're all going to be the same anyway because it's a square base. So whatever that is, we're going to times by 4 to have the 4 sides. So that would be 1,500 centimetres squared for that area. We would then times that by 4 for 4 posts, 4 sides. So it's going to be 6,000 centimetres squared. We know that it costs 2p to make 100 centimetres squared. So we could write it like this, 2p is equal to 100 centimetres squared. We want to get to 6,000 centimetres squared. So if I times that by 6, it would give me 600. I want 6,000, so I want to times it by 60. So if I times this side by 60 as well, I get 120 pence or £1.20. Okay. Next question is on parallel lines. Highlighter will probably come in handy here. It says, an architect has shown the following drawing. Can you calculate the size of each of these angles? Now, the reason why this is really hard is because they've got the parallel lines coming a weird way. I'm actually going to rotate the paper around to have them just like flat, like I'm more used to. So can I go and find out anything so far? Well, I know that I've got, in fact, actually got parallel lines going on here as well. No, that's made a C angle there, and this will have also made a C angle here. A C angle stands for co-interior angles add up to 180. So I can work out angle A quite nicely. So A is equal to 180, take away 67. So if I take away the 60, would be 120, then take away the 7. A is equal to 113 degrees. To work out angle B, well, we know this is 72, and opposite angles must add up, must be the same. Not add up to anything. So if that's 72, I can use C angles again to work out B. So B must be equal to 180, take away 72. So if we take away the 70, we get 110, and then take away the 2, we get 108. So B is 108. Okay, so now looking at these ones, if we worked out that angle there, we'd have F angles with D. So that would mean that angle there would be the same as angle D. And then if we work out that angle there, we also work out C because opposite angles are equal. So I'd be tempted to use angles on a straight line to work out this angle here. Then use angles in a triangle to work out the missing angle. You find C, and then that's also the same as D. Okay, so I'm going to do, well, we know what that is there. That would be 180. Angles on a straight line add up to 180. Take away 72 would equal 108. So that's 108 there as well. In fact, there's an F angle with B, isn't there? So we know that's 108. Then angles in a triangle add up to 180. So 108 plus the 21 comes to 129. So then 180 take away 129 is 151 degrees. So that angle there is 51. So C is 51 because opposite angles are equal. And then because of the F angle, D is also 51. It wasn't a nice question though, it was quite fussy. We're asked to draw a scatter graph. Now before I go too much further, I go and work out what the scale is here. So here we've gone from 70 to 74, so that's a jump of 4 in 10 little squares. So 4 divided by 10 tells you that each square is worth 0.4. And similarly going across here, I've gone from 150 to 155, so that's a jump of 5 in 10 little squares. So each little square is worth 0.5. So the first one I've got to plot is 170 and 82. So 170 and 82, you should always use a pencil to draw anything on a graph in case you go wrong. So I make that point there. I'm going to tick them off just as I go. 152, so I'll have to use my scale here. And 72, and again I'll have to use my scale there. But 72 must lie in between 70 and 74. So 152 would be 150.5, 151, 151.5, 152. So it must be that point exactly. If you're out, they will take a mark off there, and if you're out on more than, or at least 2, you'll lose all 2 marks. 174, so I'm going to come to 175 and count back 2 little squares, and then 86 is actually 1 there, so well, there's 175, 2 little squares back. That point. 155, which is there, and then 74, which is dead on a corner, which we like. And then 178, 90. So that must be 177.5 because it's in the middle of 170 and 180. And then 1 little square over would be the 170, 178. And then finally 162. So again, in the middle is 162.5 up to 78 there, but 1 little square back. Okay, now the next question says, look at the results that Fiona has recorded for these 6 people, do they appear to support her thinking? Now, she says she thinks that the taller you are, the greater your waist measurement is. And this is very much agree with that because it's going in a positive correlation. So I say yes, because the graph is in positive correlation. It would also suggest that something was in a relationship if it was in a negative correlation, i.e. this is saying as the height increases, the waist increases, whereas like if you're looking at the value of cars against how old they were, that would come down like that instead, because the older a car is, the cheaper it is. That would still suggest a relationship, so just because it's a negative doesn't necessarily mean no in this case. It says, give one reason, part C, give one reason why the scatter graph to estimate waist measurement other than people is likely to give, unlikely to give reliable results. Well, you can be the same height as someone but not necessarily the same weight. So I'm going to say something like people of the same height don't always have the same waist. Waist size. Okay, over the page. Says True Tool is a tool hire company. The cost of hiring a cement mixer is 13 times by the number of days plus 26, and the cost for hiring a jet washer is 9 times by the number of days plus 38. Sarah hires a cement mixer for 5 days and a jet washer for 7 days. How much change will she get from £200? Okay, so let's not forget that bit. I might highlight that just to remind myself. So don't just go and find the price, you've got to find how much change is left over from £200. So we know the cement mixer is 13 times by the number of days, which I'm just going to change from open brackets. Then I add 26. And then similarly for the jet washer, it's going to be 9 times by the number of days plus 38. Now inside the brackets is going to go in, that was with the cement mixer, which was 5 days. I'm just going to pop 5 in there. That means 13 times 5, don't know that off the top of my head. 12 times 5 is 60, so then 1 up must be 65. And then plus 26, which would take me to 91 quid. And then number of days she uses the jet washer for was 7 days, so 9 times 7, which is 63, plus 38, which is, let's go up to 71, £101. So the total cost would equal 192. And then change, which is what I was asked for, would be £200. Take the 192, which would be 8 quid. Okay. Part B says Geraint hired a cement mixer for a number of days. Lois hired a jet washer for the same number of days. They each paid the same amount of money. For how many days did they hire these tools from True Tool? Okay, so Geraint would have done 13 times by the number of days, which I don't know, so I'm going to call that X. And then I need to add on the £26. Now, you look at Lois, and hers would be 9 times the number of days plus 38. Now, the mistake that people often make here is they say, oh yeah, so we'll use Y to represent hers. Well, no, that's not true, because we're told that they hire them, so they each pays, so they should use the same number of days. So we don't need to use a different letter here. Because it's the same number of days, it would just be the same as his, X, and they paid the same amount of money, so we know they're equal to each other. So now we just want to solve that. So I'm going to look for the smallest x, which is 9x. I'm going to take 9x off each side, which would leave me with 4x plus 26 is equal to 38. I'm now going to take 26 off both sides, which would give me 4x is equal to 12. So then I'm going to divide both sides by 4, sorry. So the answer is x equals 3. So the number of days is equal to 3 days. Okay, the next question says, the diagram below shows a sketch of existing pipelines that run from T Gwyn. It also shows a proposed 180 metre gas pipe which is to be laid to Kainia. The proposed pipe bisects. Now bisects is a really important word there. That means cut into 2 equal pieces. bisects the angle formed by Teague Wing. Complete the scale drawing below. To show the proposed pipeline, you must use a pair of compasses. So I've got one of those already to complete the angle bisector. So they're even telling me I need to do an angle bisector. Use the scale of 1 centimetre is equal to 120 metres. Well, going back to this question here, I know that was supposed to be 180 metres. So if 1 centimetre is equal to 20 metres, and I have a distance of 180 metres, what do I times 20 by to make 180? Well, ignore the zeros for a minute. What do I times 2 by to make 18? That's 9. Times it by 9, times it by 9. So my line has to be 9 centimetres long. Now, to do an angle bisector, what you must do is you must open your compass. So I open it to a comfortable amount, about 3 centimetres. If I went and measured it on a ruler, it might be slightly more. Yeah, it's 3.5. Okay, it doesn't need to be an exact measure as long as it's comfortable to draw. And I hold really close to the point of the compass, and I put the point where the two lines meet. I then draw an arc, which is part of a circle, that crosses both lines. Now this bit is just purely what I like to do. I like to go and draw a little blob where that arc hits both the lines. Now, keeping my compass at exactly the same width, I draw an arc only inside the angle. So there, I move it then to the other blob, it comes here, and as long as those two arcs cross, that's fine. It doesn't need to be an exact measure. I now need to measure exactly 9 centimetres from what I worked out before. So I'm going to put 9 on that point there. I'm going to make sure that my ruler goes through that point. It's got to be dead on 9, not about 9, dead on 9. And I need to stop at 0. There. So that line should be 9 centimetres. I may even tell the examiner it's 9 centimetres to prove I know what I'm doing. Okay. The next question, now, I've got a little bit of an issue with this question when I was doing it myself. So it says, Ysgol Fron Issa and Ysgol Caiwen are two very different high schools. One school is large and in a rural area, so it's like in the countryside somewhere. The other is a small school in a town. The town in which the small school is situated has high traffic-free cycle routes, so it's quite easy to cycle about. That's what they're trying to tell me there. All of the pupils in years 7 to 10 were surveyed in both of these schools. They were asked the following: do you cycle to school? Yes or no? If you answer no, would you like to cycle to school? Yes or no? So no need for us to fill that in. We're then given all these results here. Okay, so I'm going to have to go back and check these quite regularly. See if I can get that a bit higher there. Okay. It then says which school and year group has approximately an equal split between the three categories: pupils who cycle to school, pupils who would like to, and pupils and other pupils. So I'm looking for the bars where they look like they've been split into 3 equal parts. That doesn't look like it. That doesn't look like it. That nearly looks like it, but that white bit for me is quite a bit bigger than the grey bit, so I don't think it's that. Similarly here, they're similar, but that black bit for me is quite a bit bigger than the white bit. That black bit's smaller than the other 2 bits. Same there. There's loads of white there. That one looks pretty good to me. So that is Ysgol Caiwen, and their year group is year 10. So Ysgol Caiwen, and the year group is year 10. And then says, circle either true or false for each of the following statements. There are definitely more pupils in Ysgol Fro Issa who cycle to school than Ysgol Caiwen. Well, without really doing too much maths, I can tell that's false, because this is based on the percentage. We don't know which school is which at the moment, so as a result, I can't tell you anything. That could have 2,000 pupils in it, that could have 5 pupils in it, so then the percentages, even if it looked like more people cycle to school in, say for instance, well they were pretty much all in that one, so let's say that was the really small school, if there's only 10 pupils in that school, 60% would be 6 people, but if there's 2,000 in that school, then 20% of 2,000 is obviously more than that, so we can't tell without knowing some numbers, so the answer there would be false. This is the one that I have a bit of an issue on. The mark scheme is telling me that it's true. Okay, that's what the mark scheme says. I went and checked. It said both schools have pupils in each year group with no interest. Okay, right, I've just answered my own question. Both schools have pupils in each year group with no interest in cycling. Now, I can see here 20% there, 20% there, more than 20 there, more than 20 there, more than 20 there, more than 20. Yeah, that each school does definitely have some people who've got no interest in cycling to school. Okay, so they're the others, aren't they? So that's why that's true. The questions asked were biased. Well, that's false because it's not asking them as they leave a cycling shop, would you like to cycle to school, something like that. To be biased, you've got to be trying to predict or trying to get favourable answers, and these are just asked to everyone in the school, so that wouldn't be biased. Approximately 20% of the pupils served a survey in Uskal Kaiwen cycled to school. So here's Uskal Kaiwen. 20 cycled to school there and there. Less than 20 there, but more than 20 there. So if I took that bar there, put it there, that looks like it would actually match up to having 20 throughout. So I'm happy to say that's true. And then it says, it is more likely that Uskal Fron Issa is the small school situated in the town. Now we're told that the school situated in the town, the town school, has many traffic-free cycle routes. So I'd expect that school to have the majority of people who cycle. So the people who cycle are in black, and I can see here that there's bigger proportions in these bars. So I would agree, I would say yes, that is true. Okay, it then says, part B, zoom in a bit here. In January 2011, there were 1,200 miles of cycle network, national cycle network routes in Wales. In January 2016, there were 1,400. Okay, so there's been an increase of 200 miles in 5 years. So I'm going to write that as a statement. So I did that by taking away the number of years there, or adding on years from 2011 to 2016 and adding on 200 there. So 5 years is equal to 200 miles. May come in use, it may not. If the number of miles in the NCN routes in Wales were to continue to increase by the same number of miles per year. Okay, now I've got it for 5 years. How many miles of cycle routes would there be in 2018? Okay, in January 2018. Well, I need to go and work out what 1 year is. So to do that, I'm going to divide 5 by 5, because 5 divided by 5 is 1. It will tell me how much is expected in 1 year. So I'll divide that by 5. So 200 divided by 5, I don't know. Do we know what 2 divided by 5 is? Not a nice number. What's 20 divided by 5? That's 4. And then there was 1 0 hiding behind my thumb there. So that's 40 miles per year. So we're on January 2016 and we have to get to 2018. So that's 2 years. So in 2 years, I'd expect there to be twice as many miles of routes built. So that is 80 miles. So there would be a total miles would equal 1,400, add the 80, which is equal to 1,480 miles. Part 2, why is your answer in part 1, so this answer here, unlikely to be an accurate estimate for the number of miles of NCN routes in Wales in January 2018? Well, I come from a place which is really quiet, and sometimes they're building loads and loads and loads of cycle routes, and sometimes they're building nothing at all. So I'd say something along the lines of some years, some really long cycle paths could have been made. And other years, not much at all. So for instance, they could have built, for instance, the 200 miles there, they could have built 180 in 1 year, and then just added 20 miles in the next 4 years. That is potentially what could have happened. Okay, over the page, it says, just adjust the camera there so we can see what I'm doing. William owns and runs dog kennels. His costs depend on the number of dogs in the kennels. The running costs for 1 day are shown on the graph below. Why does the graph not run through 0, 0? So we can see that line there does not run through 0, 0. So that's basically saying there are no dogs, but he still has to pay a cost. Well, why might somewhere, even if they don't have any dogs in and that's their business, have some sort of costs that they're paying out? Well, there's lots of reasons why. Rent, for one. Electricity bills, you're very unlikely to just turn off all your lights, all your water and stuff like that when there's no dogs in, and also even when you have got electricity in your kennels or in your house or whatever, you have to pay what's called a standing charge to stay connected. So even if I didn't turn the lights on in my house all year, or use any electricity, I'd still have to pay to be connected to the electricity board. So I'd say even if there are no dogs, there will still be running costs, e.g. electricity / water, etc. Okay, over the page, it says, what is the increase in the daily running costs for each additional dog that is kept in the kennels? Okay, so to do that, we need to go and work out the gradient of the graph. Okay, that's what that's telling me. The daily running costs would equal the gradient of the graph. So the gradient formula that we use is rise over run. Okay, you may know it's something else, but it basically just means how much does the graph rise up over how many times it run. To do that, we want to find two nice points on the graph. Now, when I talk about a nice point, I would not consider like this point here to be a nice point. I want it to be somewhere on the bold line, like these bold lines here, and stopping somewhere on another bold line. It can be as small or as big as you want. That seems like a good place. It goes right through a corner there, and I'm looking for another one. There's another one that does exactly that. No, I might use this one here. Now that means I always go and draw a triangle to sort of help me with my rise over run. So there to there. It means I'm going to have to go and work out what the scale of the graph is as well. So we're basically going to do the height of this triangle divided by the width of this triangle. Now the width is really easy because of where I've run it from. That's why I was looking for the bold lines. I know that it's run across 10 units. Okay. Now what I don't know how much it's risen. So I'm going to have to go and work out the rise. So 0 to 50 is a jump of 50 in 10 little squares. So each little square is worth 5. So here I've got it 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5 is 40. So then putting that into my rise over run formula, that would be 40 divided by 10, which is equal to £4 per day. Think of it as £40 for 10 days, so then for 1 day, divide top and bottom by 10. Okay. The next question says, Freda also uses a dog kennels. The cost of keeping 20 dogs in her kennels is, for 1 day, is £130. She knows that as the number of dogs increases, the overall cost increases at the same rate as William's kennels. So the cost increases at the same rate. Now that's telling you something else about the gradient. That tells you the gradient must be set the same. So gradient must be equal. Okay, so 20 dogs is equal to 130 quid. So here's 20. I need to look for 130. So the middle of 100 and 150 would be 125. Each little square is worth 5. So I'm going to draw a blob there. Now, because I know that the rate of increase is the same, that means that the line must be parallel to that. So I'm going to get my ruler parallel to that line. I'm just going to move it, keeping it parallel until I find my dot there. I'm going to draw that one there. So those two lines are parallel to me. And that is Freda. And it says, find the cost of keeping 30 dogs for 1 day. So for 30 dogs, coming up here and reading off this value here. So I am going to make that, there's 150, 155, 160, 165, I'm going to make that £170. Okay, cumulative frequency question now. So we've got the graph there. Let's go and read what some of the questions say with the chance I'm going to be drawing all over this. It says use Merriam's cumulative frequency diagram to find the median and interquartile range of the time he spends cleaning windows for each of his customers. Now that's pretty standard stuff here. So to go and work out the median, that means the middle of the total number. So the total number is 120, definitely. Just go and check that's always the case, because that number there may not be the highest point, for instance, if it was 1 or 2 down, but it is. So the middle of 120 is 160. I would recommend drawing with pencil. I'm going to do it in pen just to have sort of colour to show the difference between the lines. So there's 60 on that line there. So I need to read down again. I'm going to have to do a little bit more work on the scale here. Let's work up and down as we're going. So 20, jump of 20 in 10 little squares, so each little square is worth 2. And here, 0 to 5 is jump of 5 in 10 little squares, so going across each little square is worth 0.5. So 15.5, 16, 16.5, 17. So the answer for that is 17. Now, I like to go and write on this line what it is, just so when I go back to the question, I know what it was. So the median was equal to 17. I'm also asked to work out the interquartile range. So the clue there is in the name, quartile. Median is half. Quartile is a quarter in the first instance. So a quarter would be half of a half. So I'm going to go across at 30. So this is going to be the lower quartile. And then reading off that value there, I make that 14. Now to work out the interquartile range, which is here, I'm just going to write down this formula. Interquartile range is equal to upper quartile, take away the lower quartile. The lower quartile, take away, that should be, not an equals. The lower quartile is a quarter, 3 quarters would be the upper quartile. The trick to work it out is we know that when across at 30, add together the values of the cumulative frequency for the median, so 60, add 30, you want to go across at 90, that will work out 3 quarters. So again, drawing that line there, let's go across at 90. Coming straight down, I make that 19. So to work out my interquartile range, I want to do 19, take away 14, which is equal to 5 minutes. Part 2 says, Marion looks back at his raw data. He finds the median was actually 17 minutes and 30 seconds. So we weren't a million miles off when we said 17, but 17 minutes and 30 seconds. Why is there a difference between the median from his cumulative frequency and diagram and the actual median in his raw data? Well, if we go back to the graph, these are straight lines. Your teacher may have told you to draw like a smooth curve. I'm actually quite happy when I teach to do straight lines as well, because it will give you a reasonably accurate picture but not dead on exactly what it is. So I would say it's something to do with that. So I'd say straight lines as the graph, on the graph, would suggest constant increase, which probably isn't the case. So for instance, like talk about cans of Coke, one can of Coke costs 50p, 3 cans of Coke will cost £1.50. That's what I'd suggest by constant increase. It wouldn't necessarily mean that in terms of cleaning windows because of the size of windows, etc., etc. Okay, so would suggest constant increase, which may not be the case. Part B, Marion is looking at the time it took to clean individual customers' windows. Find the number of customers whose windows took between 10 and 15 minutes to clean. So what we need to do for that is draw a line up from 10, work out what that value is. In fact, we can see that pretty clearly because the dot's already on there. So that's that value there, which for me is 12. And then at 15, a little bit higher, 30, 32, 34. So the number of customers between 12 and 34. So what we need to do is do 34, take away that 12, and it'll tell me the number of customers in there. So 34, take 12 would equal 22 customers. Finally, it says, part C, Marion thinks that approximately 80% of his customers, he cleaned their windows in less than 20 minutes. Is Marion correct? You must show all your working. Okay, so he reckons he did it in less than 20 minutes. So I'm going to work out here from 20. Don't normally draw this many lines on a cumulative frequency graph, but I did tell you could be drawing a few. I make that 102 people. Now, he's worked out as a percentage here, so I'm going to go and work that out as a percentage. So it's 102 out of 120. Now, the problem is we want that to be over 100, not over 120 to make it as a percentage. So what I'm going to do is try and think of a number that I know I can divide that by that will be nice to turn into 100. Now, I could halve top and bottom, which would work out 60, but 60 times what makes 100? Other numbers that divide it nicely into this, potentially 5. 5 into 100 goes 20 times, so it's 24. There's not a nice number that 24 goes into that. Other numbers go into that, 12. If I divide that by 12, I'm going to get that to be over 10, and then I can times that answer by 10, okay, because 10 tens go into 100. The problem is that I don't know what 102 divided by 12 is, so I'm going to use something that we will have used back in the day, bus stop division, 102. I'm going to put in a decimal point, so notice I put it in my answer as well, above. I'm going to put in a couple of zeros. I may not need to use all of those, I may have gone overkill. I'm counting 12s until I get to 1, none, into 10, so I've carried it across the remainder, still none, into 102. So 12 times 8 is 96, and then 12 times 9 is 108, so that's too many. So I'm going to go back to the 96, which would be 8 times 12, which gives me 96. 96, count up to 102 would be a count of 6, so that's my remainder. And then how many 12s go into 60? The answer is 5, so yeah, these were needless, I didn't need to write them in. So my answer is 8.5 out of 10. Now, strictly speaking, I shouldn't have a fraction with a decimal in the fraction, but because I'm going to times it by 10 to turn it into percentage, that's how I do it. So I'm going to times that by 10 as well. 8.5 times by 10 is 85%. 85 out of 100, which is 85%. Now, he said he thinks he gets approximately 80 of his customers. I'd agree, yes, he does. Yes, in fact, slightly more. From the data in graph. Okay. Okay, then the next question says Megan Pugh's electricity bill is shown below. It covers a period in May, June, and July 2017. So we hold the previous meter reading is this, the present meter reading is this. So we've used a number of units of electricity. In fact, it tells us it's 450, so if you add 450 onto that, it will give you that. Usually you have to go and work that out. Charge for 450 units at 20p per unit is 90 quid. Standing charge 3 months is £7.60, it's £22.80, so they've done 3 times that to work that out. Total charges is that, so they've added those two together to get that. VAT at 5% of £112.80 is £5.64. So the amount to pay would be the total charges and the VAT. On the 1st of August 2017, the charge per unit of electricity was increased by 5%. So what is the charge per unit currently? It's 20p currently, and we're going to increase that by 5%. So first of all, I'm going to find 10% of 20p is equal to 2 pence. So 5% would be equal to 1p. Now, because we're increasing that, we're going to add it onto the 20p. So 20p add 1p would be 21 pence. Part B. Megan wants to calculate her next 3 monthly electricity bill. She knows the following. Her meter reading on the 31st of October was 14,400. The charge per unit of electricity is increased by the 5% since her last bill, so it's that answer there. The standing charge is increased by 20p per month. So it's currently £7.60. It's now going to be £7.80 per month. P/M per month. And that remains at 5%, so that's still the same. On the 31st of October 2017, Megan had £470 in her bank account. After paying her next 3 monthly electricity bill, will Megan be able to buy a new washing machine costing £330? You must show all your working. So 9 marks here. So we've got to take our time here. So we want to look back at that previous stuff there. So I've got it just to hand here, so you'll still want it to hand. Okay, so first of all I'm going to work out the units used. So the units used, her new bill, or her new meter reading was 14,400, and it was previously, after her last bill, 13,900. So I need to go and work out the difference between those. Nothing take away nothing is nothing. Nothing again. 4 take away 9 I can't do. It's minus 5. I've got to borrow 1. So that's 5. So it is 500. So units used is equal to 500 units used. How much are we paying them for a unit? So the unit has now gone up by 5%. So that's equal to 21p per unit. So I've just written there, 21p per unit. So I need to do 500 times by 21p. Now there's a smart way to do this. If I ignore the 2 zeros there, 5 times 21, we should know what 5 times 20 is, that's 100. So 5 times 21 would be 105. And then I want to add on the 2 zeros there. So that is going to be 10,500 pence. Other ways to do it, you could have split it up. There's multiple ways to do long multiplication. And then I'm going to divide it by 100 to turn it into pounds. So that is going to be 105 pounds. Okay. We then have to pay the 3 monthly standing charge. So as we said before, 3 months at £7.60 per month times 3 by £7.60 worked out that number. This time it's different. It's 3 times by £7.80 as we've already discussed. So I'm going to split that into £7 and maybe 0.80, or we could say 7 and 80p, and then add them on there. So I might do that. I think it would be slightly easier. £7 times by 3 is £21. 80p times by 3 would be 240 pence. So that is going to be £21 at £2.40, which is going to be £23. £23 and 40 pence. Okay, so I've got that amount for the units used, that amount there, and I need to go and work out what the total charges are, because as they did before, they worked out the total charges and then they worked out 5% of that. So total charge would be equal to 105, add the £23.40. So I make that still the 48 there, 2 there, 1 there. So £128.40. I now need to go and work out that at 5%. It said it remains at 5% there in my question. So 10% of £128.40 would equal, so we'd divide by 10, so the numbers would move down one place, so that would be £12.840. We wouldn't need to write the 0, but money does have to be to 2 decimal places. Luckily for me, it already is. So 5% would be equal to half of that. So half of £12 is £6. Half of 84 is 42 pence. Doesn't always work that nicely. We may need to do some bus stop division, but it did work quite nicely because all the numbers were even. So, amount to pay would be the total charge, so £128.40 plus £6.42. So 2, 8, 14, carry the 1, 3, 1. So it is equal to £134.82. Now, just go back and check that we've answered the question. There's 9 marks available here, as we said. It says, after paying her next 3 monthly bill, will she be able to buy a new washing machine costing £330? She has £470 in a bank account. So if we do £470, let's say 0.00 there as well to work out taking away that. Take away how much the bill has cost. So that's 82 there. Nothing take away 2 we can't do. We need to borrow 1 from here. There's nothing there. There's There's nothing there. I'll have to borrow all the way from here. So I'm going to have that as 6 and that's 10. Now it's got something, I'm going to borrow one from there, and now I can borrow one from there. So a bit fussy, that one. 10 take away 2 is 8. 9 take away 8 is 1. 9 take away 4 is 5. 6 take away 3 is 3. 4 take away 1 is 3. So she has she has £335.18 left in her account. Now, in terms of what we were asked, it says, will the machine, will she be able to buy a new machine costing £330? So yes, she can buy a washing machine, as she has more than £330. So she can do as she wants. Okay, number 12. We've got some box plots here. So the first thing I'm going to do is start writing some numbers on each of those sort of lines there. So we've got our lowest value, our lower quartile, our median, our upper quartile, and our highest value. So these are all quite nice, yet they're all roughly, they're all exactly the same scale, and each little square is worth 1. So that's 42, that's 50, that's 61, that's 80, and this one's 83. The one underneath is 40, it's 46, that's 57, that is 75, and this one's 80. And underneath here, this is 42, this is 46, this is 63, this is 79, and this one is 84. Okay, so we could be asked to work out the medians. Well, the medians I've already worked out all of them, 61, 57, 63. We could be asked to work out the interquartile range, so this is the upper quartile, lower quartile, it's supposed to be an L, sorry. This is the median. This is the min value, and this is the max value, the highest and lowest ones. Okay, so we're asked. It says complete the following statements. Apples from the something apple tree have the least median width. Okay, so the least median width belongs to this one here, which is 57, 61, and 63 are bigger. So it's the orange pippin tree. I've spelled orange wrong there. So orange pippin apple tree, and the median for them recorded was 57. Okay, it then says the range of the width of apples recorded for the Gala apple tree. So the Gala apple tree was the top one, and they want me to work out the range. So that's the max value. So 83 take away 42, which I make that as 41. Worked out quite nicely. Otherwise, I'd have had to do column subtraction if needed. It then says part 3, the something apple tree has apples with the greatest interquartile range of width. So we're looking for the biggest width in between these ones. So that's going to be 80, so interquartile range. 80 take away 50, which is 30. This one here is 75, take 46, so I will set that up as column addition. Can't do that, so 15 take away that is 9, 29. And then this one here is 79, take away 46, 33. So it's this one here. These are all interquartile ranges, just my own use. So that's the greatest value out of those three there. So that is the pink lady. And the interquartile range was 33. It then says, which tree has a higher proportion of larger apples? You must give a reason for your answer. Higher proportion of larger apples. Well, I'd be looking at the median for the highest median, saying, well, half of these apples are bigger than 63, so I'm going to go with pink lady. So pink lady as half apples, half of the apples are above 63 millimeters. Okay, last question on the test or on the paper. It says, Emily has a photograph he wants to enlarge. The diagram of the original photograph and the diagram of the enlargement are shown below. Now these will be in what is called scale factor because it's enlargement, so you stretched it the same both ways. So we want to look for a measurement that we know the same on both, or the equivalent side on both, which is 6 and 15 is the length. So I know 6 times by the scale factor would be equal to 15. So the scale factor would be 15 divided by 6. Now I don't know what that is because 6 doesn't go into 15, so what I'm going to do is I'm going to cancel that fraction down. So I know 3 goes into both. So 15 divided by 3 is 5, 6 divided by 3 is 2, 5 divided by 2 is 2.5. That's a little bit easier. So what I've done is I've made this 2.5 times bigger, or you could argue that I've made this 2.5 times smaller. So I'm supposed to go and work out the height of the enlargement here. So what I want to do is do 4 times by 2.5. There's a couple of different ways you can do it. My personal favoured way of doing it is saying, well, 4 times 2 is 8, 4 times 3 is 12, so 4 times 2.5 must be in the middle of those, and in the middle of those is 10, but obviously with 4 you could times by 2 and then times by 2 again, which is also 10, so it's 10 centimetres. But let's make sure the answer is really obvious. I'm going to say height equals 10 centimetres. Okay.